Hello everyone, this is Jivika Kancharla and I'll be explaining you guys the second question of homework 2 of the course Probability and Stochastic Processes. So in the second question, as you can see, there are x1 to xk plus 1 data signals. X1 is the first input data signal which is going through a noisy channel and it generates an output of x2 data signal, and as it goes xk will be one of the input signals which will go into a noisy channel and will give an output of xk plus 1 output signal. Now given probability that x1 is equal to 0 is equal to 0.2, as you know, for each input signal data the value can be either 0 or 1. So the probability that x1 is equal to 0 is 0.2. The probability that x1 is equal to 1 is 0.8 for all values of k which is in between 1 and n. Now the probability of xk plus 1 is equal to 0 given xk is equal to 0 is 0.6, and the probability that xk plus 1 is equal to 1 given xk is equal to 0 is equal to 0.4. Also the probability that xk plus 1 is equal to 0 given xk is equal to 1 is 0.3, and the probability that xk plus 1 is equal to 1 given xk is equal to 1 is 0.7. Now in the question we are supposed to find probability that x2 is equal to 1. So let's see the solving of this one. Yeah, so I've just drawn the diagram as given in the question, and I have written all the probabilities that are given there. Now as you can see, let's consider this part from x1 noisy channel and x2. Let's take an assumption of what's happening here. X1 has two input signals, that is 0 and 1, and x2 has two output signals 0 and 1. When 0 is transmitted through a noisy channel, it can generate a 0 data signal or a 1 data signal, and when 1 is transmitted through x1 it is transmitted through a noisy channel, it could generate an output of 0 or 1. Now the probability that x2 is equal to 1 can be in two conditions, that is when x1 is 0 and when x1 is 1. Now we can calculate the probability of x2, that is p of x2 is equal to p of x1 is equal to 0, that is probability that x1 is 0, and when x2 is equal to 1 given x1 is equal to 0, that is this condition, and probability that x1 is equal to 1 into the probability that x2 is equal to 1 given x1 is equal to 1, that is this condition. Now when we substitute all these above values into this equation, we will get an answer of 0.64. Now the second question is find the probability that p of x3 is equal to 1. Let's solve this. From this solution, we know that the probability that x2 is equal to 1 is 0.6. Now, what will the probability be for x2 is equal to 0 is 1 minus 0.64, which is equal to 0.36. Now, same as the above question, the probability that x3 is equal to 1 can happen in two conditions, that is, let x2 will have two input signals, that is 0 and 1, and x3 will have two output data signals 0 and 1. Now the probability that x3 is equal to 1, that is this one, will happen in two conditions, that is when x2 is 0 and x2 is 1. Now let's calculate p of x3 is equal to 1, which is equal to p of x2 is equal to 0 into p of x3 is equal to 1 given x2 is 0, that is this condition, and p of x2 is equal to 1 into p of x3 is equal to 1 given x2 is equal to 1, that is this condition. Now when we substitute all the values, that is x2 is equal to 0 is 0.36, that is we calculated from here, and 0.4 is given above, and x2 is equal to 1 is 0.64 into 0.7, that will give you an output value of 0.592. The third question is find p of x1 is equal to 0 given x3 is equal to 1. Now for this question we will use Bayes' theorem to solve. Now according to Bayes' theorem, we know p of probability of A given B is equal to probability of B given A into probability of A divided by probability of B. Now in terms of A, let's substitute x1 is equal to 0, and in terms of B, let us substitute x3 is equal to 1. So what will we get here is that probability of x1 is equal to 0 given probability of x3 is equal to 1, that is equal to probability of x3 is equal to 1 given x1 is equal to 0 into probability of x1 is equal to 0 by probability of x3 is equal to 1. Now to solve this, first let's calculate the probability of x3 is equal to 1 given x1 is equal to 0. We can calculate this, that probability of x3 will be 1 in two conditions, that is when probability of x2 is equal to 0 given x1 is equal to 0, and to probability of x3 is equal to 1 given x2 is equal to 0 and x1 is equal to 0, plus probability of x2 is equal to 1 given x1 is equal to 0 into probability of x3 is equal to 1 given x2 is equal to 0 and x1 is equal to 0. Now when we substitute all these values that we've computed in A and B, that is here and here, we will get an answer of 0.52, which is the value of probability of x3 is equal to 1 and x1 is equal to 0. Now substituting this value and probability of x1 is equal to 0 and x3 is equal to 1, we will get the value of 0.1756, which is the probability that x1 is equal to 0 given x3 is equal to 1. Now the fourth question is, find the limit n tends to infinity probability of xn is equal to 0. To solve this question, we know that let's consider limit n tends to infinity probability of xn is equal to 0 is equal to p. That is, therefore for n tends to infinity, p is equal to limits of n tends to infinity probability of x is equal to n. Now we know for infinite numbers in mathematics, if p of n is equal to 0, then p of n minus 1 will also be equal to 0. Therefore for p of n is equal to 0, we write it as p of n minus 1 is equal to 0 into p of n is equal to 0 given p of x of n minus 1 is equal to 0 plus p of x n minus 1 is equal to 1 into p of xn is equal to 0 given x n minus 1 is equal to 1. Therefore for limit n tends to infinity, probability is equal to, when we substitute all these values, since we assumed that p is equal to limit n tends to infinity p of xn is equal to 0, which is equal to limit n tends to infinity p of x minus 1 is equal to 0. So here we will be substituting p, and we know this value is equal to 0.6. This will be 1 minus p into 0.3. When we multiply and subtract all of this, we get an equation of form p is equal to 0.3 of p minus 0.3. When we solve it, we will get p of p is equal to 3 by 7. Therefore limit n tends to infinity p of xn is equal to 0 is 3 by 7. So this is the solving for the second question.